Okay, you guys, so this is video 5E2, which is still using our law of cosines that we used in the last video, but this time instead of finding a missing side, we're going to be finding a missing angle. There's a few more steps involved, so that's why I wanted you to find the missing side first, and that way we can use that knowledge about where things go in the formula to just take things a little further with finding a missing angle. Before we get started with example 2 from your textbook, I want to just give you a couple of reminders that I think are important to keep in mind about the law of cosines. So what we want to do is we want to go ahead and remember about notation that the capital letters mean that we're referring to angles and that our lowercase letters refer to our sides. Okay, so just remember that. The second thing I want to remind you about is as far as organization goes, the number of calculations involved in these problems, I think you've already seen, is pretty steep. So make sure that you are writing neatly and small, if at all possible. If you are challenged by writing in a neat and a small manner, then don't try and smush all your calculations into the space that I've given you on this whisk form, okay? Grab some scrap paper and make sure that you're labeling with the name of the video so that it can go in your portfolio, but don't be limited by what I've given you, okay? Set yourself up for success. So let's move on to example 2. The triangle that we're working with in example 2 is triangle QRS, and the sides that we know are as follows. And so we want to make sure we put labels on each of those. 37 is opposite Q, so that becomes my little q. 23 is opposite R, angle R, so that becomes my little r. And 18 is opposite angle S, so that's going to become little s. Then this time, instead of knowing two sides and an angle and finding that third side, we're going to know three sides this time and have the unknown be an angle itself, okay? So with triangle QRS, we obviously want to modify the law of cosines equation that we had from the very beginning of our videos because those aren't the right letters that we're working with anymore. So notice that what we want to find is angle R, and so what we want to start the equation with is r squared. I hope that that makes sense to you, because if we're finding angle r, then that means angle r has to be in the equation itself. So that means cosine of r is what we're finding, which remember corresponds to way down at the left end of the equation. If this is capital R, then this is lowercase r. And the other two variables we'll put in alphabetical order, so q squared plus s squared minus 2qs cosine of r is how that's all going to get filled in. So let's plug in our values, okay? We're going to have 23 and square it equals 37 and square it plus 18 and square it minus 2 times 37 times 18 and times cosine of my unknown angle r. So as I'm looking at this, we want to make sure that we're going to solve for angle r, but before we do that, we're going to solve for cosine of r. And so as we work through these calculations, you can do it bit by bit on your calculator. I would recommend that you do quite a lot of the writing down and of the calculations first on paper before you get to a point where you want to do it in your calculator. The screen capture video of the TI calculator steps that I've created for you guys does have a little bit more of involved steps for this, so make sure that you view that to help you as well, okay? As we're going through here, we get 529 for 23 squared. We get 1369 for 37 squared, 324 for 18 squared, and then this product right here, the 2, the 37, and the 18, multiply to be a negative 1,332 times cosine of r. So as we're looking at this equation, we want to start trying to move things out of the way and get cosine of r alone, okay? So as we're looking to do that, we probably want to combine these first two numbers. So we get 1,693 minus 1332 cosine of r. And then that's still equal to the 529 that was there before. Just like before, I want to caution you that this 1332 is glued with multiplication times that cosine. So I can't combine that with this constant. It's tempting to do that, but please don't, because you will get the problem wrong. So what I can do is consider this an equation where I can still move a constant out of the way. And when we do that and we subtract the 1693, we get negative 1164 is just equal to negative 1332 times cosine of r. Now remember, to get to r, we want to get to cosine of r first. So we want to think about how it is that we would get cosine of r alone here. And as we do that, we want to think about just simply dividing by the coefficient in front of that value. And so if we divide both sides by that negative 1332 on the left-hand side and the right-hand side, then that's going to give me cosine of r all alone. And cosine of r is going to be equal to the ratio 1164 over 1332. So what I need to remember at this point is that if I want to get an angle out of any trigonometry equation, I have to use the inverse cosine or inverse sine or inverse tangent, whatever ratio it is that we're working with. I need to use the inverse of it to undo it. There's no such thing as dividing by cosine, remember. So I need to take the inverse cosine to undo this ratio. So r is just simply going to be equal to cosine inverse, which remember is that second function button on your calculator, cosine inverse 1164 over 1332. And you guys, this is where I would start using my calculator. Notice I did all of these steps. Of course, I'm using my calculator to do the squarings and things like that. But I'm not actually getting a trig function put into it until the very last step here pretty much. So cosine inverse of 1164 over 1332. And of course, now we're going to get an approximation. So an approximation for that is around 29 degrees. Okay? So my unknown angle here, angle r, is 29 degrees. And that is how you go through the process of when you start knowing 3 sides to begin with in a triangle, finding one missing angle. In the next video, we'll do another one of these. Like I said before, it's not going to be from your textbook, but it is going to be the same type of calculation. And we'll go through one more, and then, of course, on the back of your whisk, you have that third example that you can check on your own to make sure that you understand what we've been talking about. So I'll see you guys tomorrow.